Hello there, this is Mr. Greasy Roche and his sidekick Wilson, and welcome to Mr. Roche's Foot Class Math 10 No Frills, No Thrills, Low Budget, Low Tech videos. As well as Mr. Wilson today, we've got a special treat. It's a live audience. Oh, they're a live audience full of comedians. There we go. And back to the show. Here we go. Hey, that rhymed. Okay, in this video we're going to be doing Systems of Linear Equations Part 3, Solving Systems by Elimination. So in this lesson we'll be learning how to solve systems by either adding or subtracting terms in order to eliminate a variable. Okay? So here's some nice easy steps to follow. If necessary, we're going to rewrite the equation so the coefficients are integers. It's a real bummer doing this with fractions, so don't try. Then rewrite one or both so that a variable term in both equations are either the same or opposite. Okay? Now one variable can be eliminated by subtracting or adding the equations together. Once one variable is solved, we can finish by substituting the original equations for our we can substitute into one of the original equations and verify by subbing into the other. So the second part is a lot like substitution. Okay, here we go. This one's really easy because one of the variable terms is already the same. So I can get rid of that variable term simply by subtracting these two equations. So I'm going to subtract. So 3x's minus 5x's is negative 2x's. 4y's minus 4y's is no y's. And then 12 minus 8 is 4. Okay, now I'm going to solve for x. Divide this out by negative 2. X equals negative 2. So if they want me to just say what x and y is, I could just list them. X equals negative 2 and y equals whatever we find. Or I could list them as an ordered pair. Okay, let's find out y. So now, like substitution, I'm going to just substitute this value in for either of the x's here in order to find y. Let's try the first one. 3 times negative 2 plus 4y equals 12. That's negative 6 plus 4y equals 12. Bring that over as plus 6, and I have 4y equals 18. Divide side by 4, and I have y equals 4 1/2, or 9 halves. Okay, now we go along to this one. And I'm going to put the same value for x into this equation to see if I get the same value for y. If I do, it's verified and it's got to be right. So I have 5 times negative 2 plus 4y equals 8. That's negative 10 plus 4y equals 8. That's 4y equals, I'm going to bring that negative 10 over as positive 10. So 8 plus 10 is 18. Dividing side by 4, and I get y equals, if I reduce that, 9 over 2. Same answer, it's verified, it's got to be right. My studio audience is so impressed, they're just going crazy in the background right now. Yeah. Okay, here's another one. Yeah. So in this question, I'm not quite sure if I'm going to add or subtract yet. First of all, what I have to do is change one of the equations so that we end up with, or maybe I have to change both, but we need a pair of opposite or identical variable terms. So in this case, you can see that if I was to double this equation, I would have negative 4x's. And then that would be the opposite of 4x's. That would be my easiest change in this particular question. If I wanted to change my y's, I would end up having to make it so I had 35 y's here and 35 y's here so that I could either add or subtract them. So I'm going to double everything in this equation here. Double everything. So that would leave me negative 4x plus 10y's equals 6. These two equations would be collinear if I graph them. They're the same line. So all my solutions are going to be the same. So now I have this equation that I'm going to combine. Because I have a 4x and a negative 4x, I'm going to add these two. Okay? So I'm going to completely ignore this one right now and add this one to this one. So 4x's and negative 4x's is 0x's. 7y's and 10y's is 17y's. And 11 plus 6 is 17. Well, this is going to work out nicely. I divide side by 17, and y equals 1. Okay? So 1 is the y. Now I'm going to solve for x. So I'm going to substitute 1 in for this y. So 4x plus 7 times 1 equals 11. 4x plus 7 equals 11. 4x equals, I'm going to bring the 7 over as minus 7. 11 minus 7 is 4. Divide side by 4, and x equals 1. Okay? Just coincidence that these two are the same. But we better verify it. Let's see. I'm going to put this y1 in for the second equation. This is the one that I kind of crossed out right here. So I have negative 2x plus 5 times y, which is 1, equals 3. Negative 2x plus 5 equals 3. That's negative 2x equals, bring the fly over as minus 5. 3 minus 5 is negative 2. Divide that by negative 2, and x equals 1. Perfect. It's verified. Okay, I've got a couple more examples that are getting progressively more difficult. Okay, in this one, I can't just double 1 or triple 1 and end up with a variable term that's going to be the same or opposite. In fact, I'm going to have to change both. So I have to decide, am I going to make the x's the same or opposite, or the y's? It doesn't really matter. I like to pick on the smaller coefficients because it keeps my solutions smaller. So I'm going to make these the same, the y's. So if I was to double this equation, I would have 6y's. If I tripled this equation, I would also have 6y's. Okay? So I'm looking for like a least common factor of these, or rather, least common multiple of these two. Okay? So here we go. I'm going to double this one, and I'm going to triple this one. Okay, so that would leave me, I'm going to rewrite it in a different color for now. 2 times 6x is 12x's. 2 times 3y is positive 6y's. And 2 times 5 is 10. My second equation, I multiply everything by 3. That would be 15x's. 3 times 2y is positive 6y's. And 3 times 8 is positive 24. As you can see, these are now the same. So I either have to add or subtract these. Well, in this case, I would subtract to get 0 y's. Here we go. 12x's minus 15x's is negative 3x's. No y's. 10 minus 24 equals negative 14. This one's not going to work out very nicely, but hopefully it's still good. X equals positive 14 thirds. So that's part of my solution. Okay, now we're going to try and find out what the value for y is. So I'm going to put this value in for, might as well put it into the original. 6x, 6 times 14 thirds plus 3y's equals 5. I can do a little bit of reducing here. I could go 6 times 14 and then divide by 3, or I can reduce first. That's 2 and 1. That's 28 plus 3y's equals 5. So now that's 3y's equals, bring the 28 over as minus 28, and I get negative 23. Divide that by 3, and I get y equals negative 23 thirds. Well, that's not very nice. Hopefully this checks out okay. If not, I've made an error somewhere. So I'm going to put the same value for x into this equation. 5 times 14 over 3 plus 2y's equals 8. This doesn't reduce, so I have to go 5 times 14, which is 70 over 3. Plus 2y's equals 8. That's 2y's equals, I'm going to go 8 minus 70 over 3. But to make that subtraction easier, I'm going to make this into thirds. 8 wholes is 24 thirds. So 2y's equals 24 minus 70 is 46 thirds. Okay? I really don't like this fraction anymore. I'm going to multiply both sides by 3 and eliminate it. Multiply this side by 3 and this side by 3. These cancel. So now I have 6y's equals 46. Now I'm going to divide each side by 6. And y equals Well, if I reduce this down, I could half that. Half of 46 is 23, and half of 6 is 3. 23 thirds. Oh, somewhere my sign's not right. This should have been negative 46. Negative, negative. Now it checks out. So good thing I verified. I might have missed something there. Okay, one last example. I'm not sure how my time is going to go. I might have to cut this one off. But at least I want to get to the point where I'm not dealing with fractions. Okay, so as you can see, we have fractions in both of these. So first step is to rewrite these without fractions. So in order to get rid of this 2, I could double every term. Double that term, and that term. Okay, now that will result in 6 x's. These would cancel. Minus 1y equals 10. And how would I get rid of the 3 and the 4? I have to multiply by at least common multiple. So I'm going to multiply every term by 12. So 12 and 3 reduced down to 4. 4 times 1x is 4x's. And 12 and 4 is 3 when I reduce, 3 over 1. 3 times 1y is positive 3y. And 12 times 3 is 36. Okay, there. Now I'm dealing with whole or integer coefficients. It's going to be much easier. So as you can see now, I could make these ones addable or subtractable simply by tripling this top line. By doing that, I will have negative 3y's, which I can add to 3y's to get rid of it. I'm just going to check my time. We're doing good. I think I'll just finish. Okay, so I'm going to, what I say I'm going to do, I'm going to triple this one here. So that would be 18x's minus 3y's equals 30. So this one is now this one. So these are the two that I'm going to solve. That's my new system. So what am I going to do? I'm going to add these two to get rid of these terms. I'm going to eliminate those two terms. 4x's and 18x's is 22x's. 3y's and negative 3y's is no y's. Equals 36 plus 30 is 66. Oh, this is going to work out nicely. So x equals 3 wholes. So that's part of my solution. 3. 3 what? Well, let's find out. Okay, we have, I'm going to go back. If I made a mistake from here to here, and I check this, it might not show up. I want to go back all the way back to my original, and then I can be sure in case I made a mistake in this step. So let's see, I'm going to go back to here. 3 times 3, because the x is now 3, minus 1/2 y equals 5. Okay, so that's 9 minus 1/2 y equals 5. That's negative 1/2 y equals, bring that 9 over as subtract 9. So that's negative 4. Now I'm going to, if I multiply both sides by negative 2, I'll get rid of that negative 1/2. Negative 2 on this side, negative 2 on that side. You could do that in 2 steps. You could get rid of the 2 by multiplying both sides by 2 and then worry about the negative later. But I got rid of the 2 and the negative all in one shot. So I'm left with 1y, or simply y, equals 8. We better verify this one because it's pretty difficult. Let's see. This one, 1/3 times 3 plus 1/4 y. 1/3 times 3, 1/4 y equals 3. Made a mess of that one. Y. Okay, so these would cancel. I would have 1 plus 1/4 y equals 3. I'm going to read that 1 over as minus 1. So that's 1/4 y equals 3 minus 1 is 2. And I'm going to get rid of that 4 by multiplying both sides by 4. These 4's cancel, and I have y equals 8. Perfect. Verified. And that's it. That's as tough as they would ever get. Okay. I'd like to thank you for joining me. Thank you, live audience, and thank you, Wilson, for running the camera.
Woo!
Yay!
That was fun.